Hey guys, welcome back to another video. Today we're going to be looking at Leetcode 1011, capacity to ship packages within D days. This is a medium difficulty Leetcode problem, and the problem description tells us that we have a conveyor belt that has packages that must be shipped from one port to another within days of days. So we're given we're told that we're given a conveyor belt that has packages that must be shipped within days, and the ith package of the conveyor belt has a weight of weights I. So we're given a bunch of weights, and each index is a package, and the value at each index is the weight of that package. And each day we want to load the ship with more packages on the conveyor belt in the order given by the weights. And we must not load more weight than the maximum weight capacity of the ship. Now this is critical. Return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within days. So let's look at an example and it'll make more sense. So in this example, we have a bunch of weights, which represent the weights of the packages. Days is equal to 5, and the output is 15. Why? Because 15 is the minimum capacity for all the packages to be shipped in 5 days. Right, what if we chose something different? Instead of 15, I don't know, what if we chose an arbitrary, let's pick 3. We picked 3, right? So what would the ship look like, right? So the first ship would contain 1 and 2. Yeah, that works fine. The second ship would have a weight of 3. Yeah, that's fine because the max capacity is 3. Ship 4. Well, ship 4 we couldn't put 4 in. We're told that we're not allowed. We're not told that we can split up packages. So we basically aren't able to put this package or any of the packages which are greater than or equal to this package as well, right? None of these packages can be shipped because they won't fit the ship capacity, and so that would not work. 3 would not be correct. The output is 15, and you might say, well, let's totally just forget about the days and let's just pick the biggest capacity. What's the biggest capacity? Well, the biggest capacity is going to be the sum of all the numbers, isn't it? The sum of is 55. So why didn't we just create a huge, super big ship, huge freight ship, and that has a capacity of 55, and plop all of these packages in, boom, let's be on our way. We can't do that because the days is equal to 5, and we want to choose the minimum capacity that will result in all the packages being shipped within those days. So we want to get all those packages done, shipped within those days, but we really want to put as few as possible as we can. So let's kind of like plot this, right? What would work, right? So 10 packages, 15 packages, 20. So if we look here, right, would 10 packages, a capacity of 10 packages on each ship work? Well, no, it would not. What about 15? Well, we know 15 works. 20 would also work. 25 would also work, as in, we could still add, it would still be 5 or less days to send all, these packages on ships. So, it wouldn't be greater than 5, but it's not going to be the minimum capacity. The minimum capacity is 15. So we basically want to get the minimum capacity. How do we want to do that? Well, we can say, well, we already, it's gonna, what is our capacity going to be? Well, we already found our upper bound, right? Our upper bound is the sum of all of these values. So in this example, the sum is going to, the upper bound is going to be 55. The lower bound here is 15. Well, the lower bound is going to be the lowest or the biggest value. In this example, it's going to be 10. So the package size, which is the biggest. So we know our result is going to be somewhere between 10 and 55, right? These are our lower bound and our upper bound. And so what we can do is just do a linear progression, right? We can just linearly go through our entire list or this entire range, and we'll have a function, let's say, this function that we can put in a capacity and return an output, and this output will be just a Boolean. Actually, it will just give us a true or false value, and it will basically just tell us, can we send packages within or less than 5 days, right? Or the number of days that we are given in our function. So that's what that function is going to do. And so we would go through each of these values in this range, and test this function against or test each value against the function. And that would be not an optimal solution, right? We'd have to do this linearly. We'd have to do it for every single value, okay? And what would be a better way to solve this? Well, a better way to solve this would be using binary search. So binary search would help us because it means that we have this black box function, which gives us a true or false. We can say, once we find a value, let's say a value is true. So we want to say, well, let's find a value which is smaller. We know we can do this in, I don't know, 4 days, but let's try to do this in 5 days, right? So let's get let's get a bigger value. Or in the case where the value is too low, we want to move to the right. So we want to move our right point, or we want to move our left pointer. So we basically want to shift. We want to look at all capacities to the right of our pointer that we are at. So let's say we pick, I don't know, a capacity of 10. Well, 10 is going to give us false from this function, this black box function that we're creating. And so we want to look at, 12, 13, 14, etc., 15. We want to look at the next capacities that are greater. If our capacity is like, I don't know, 25, well, we can say, let's look at smaller capacities. Let's look at smaller values. So I hope that kind of makes sense. Let's get straight to coding, and I think it'll make more sense once we actually get to coding. So the first thing we want to do is create that black box function. And when I said black box, I meant kind of a function which just abstracts the main logic from the binary search. So it's going to just take in not can ship, and the cap is just going to be an integer, and we're just going to return a boolean. So we'll just return a boolean, and we're going to have days, which is going to be equal to 1, and we're going to have current, which is going to be equal to 0, and we're going to say for each weight in weights, if current plus weight is greater than the cap, in this case we can increment our days by 1, and this is because we won't be able to put all the weights on a single ship. We now need to have another ship. So we can imagine days as ships, but yeah, basically it's going to take another day now, another ship, and we're going to reset our current by 0, else we shall just increment our current value by weight, and then we just want to return is d less than or equal to days, right? And this basically, now we'll call this method pass capacity, and it'll tell us, will it take less than days to ship those packages? True if so, and false if not. Then we want to have our bounds, right? Our left and right pointer for our binary search. We said that we want to get the maximum value of weights. Our left pointer, right pointer is going to be equal to the sum of weights, and we want to say while left is less than right, but the median value is going to be equal to left plus right divided by 2, and if can ship, so if we can ship the mid value, we want to say let's now look on the left hand side. So let's keep looking for smaller values. We found a value which satisfies our condition. Let's look for smaller values now. So right is going to be equal to mid, else we want to say left is going to be equal to mid plus 1. So now we want to look for larger values because our value is too small, our capacity is too small for our ship. And then we want to return our left point. Our left point is going to be where our result capacity sits at. And then we just want to submit our code. And we get the wrong answer because we're probably doing something wrong somewhere here. So let's look at that. Left pointer, okay, looks lush. Sum of weight, max of weights. Okay, so here we keep on setting current equal to a single weight. We want to increment that weight. We don't want to keep setting it to the same weight over and over or to a new weight. So that was throwing off our calculation. So that we want to increment. And there we go. We passed all 90 test cases for this problem. And yeah, I hope this video made sense, guys. I hope the problem description and the way we solved this problem made sense. And understanding the problem and both solving it, getting it coded up is relatively simple, but really coming up with a solution can be quite confusing. And it reminds me of, I believe it's Leetcode 875, Coco Eats Bananas. And it's basically the same kind of solution. So I definitely recommend watching that video and solving that problem as well. In terms of time complexity, well, time complexity for, it's going to be something that we need to think about. Time is going to be, of course, we are doing binary search, so it's going to be big O of n, because we know this is linear. So n times by log of the sum of weights. So we're doing binary search, multiplying it by n, and space is just going to be big O of 1. So I hope that made sense, guys. I hope the time and space complexity also checks out, and that everything tracks. And with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.